Right, so we're ready to go.
Yeah,
Can you see me nice and clear in the Florida sun?
yeah.
That's awesome. All right, so let's get this party started. Welcome back to the Drive to Work Wednesday, our weekly live call in the HVAC Game school community. And it's awesome to have you join. It's pretty amazing. And let's get into the first question of the day. Do we have any community questions?
Not this week.
Not this week. Well, that's very sad. The first agenda then is to take up a thing that I said last week, and I have to correct myself because in the end I was driving and I guess I wasn't really thinking clearly, but that's just my excuse. I should know better. But basically, I was saying that you charge TXV devices using superheat and fixed orifice using subcooling. And I don't know why I said that because it's the exact opposite. So I apologize for the incorrect information. The way you charge TXV systems is by subcool because the TXV already automatically regulates the superheat. The job of the TXV is to regulate the superheat in the evaporator. So you charge by using the subcool method. Usually it will tell you on the data tag what the subcool is supposed to be. When you have a unit with a fixed orifice, you're charging using the superheat method because the fixed orifice does not regulate or open or close, allow more or less refrigerant. So you have to make sure that you are not getting liquid refrigerant to the compressor. You have to also make sure that the right amount of charge is in the system, which is why you are charging using the superheat method. So I wanted to clarify that because I said that incorrectly last week, and I don't want to have like incorrect information. So that's the first point of the agenda.
Okay.
Yes, I apologize for that. So let's move on. So one thing I wanna pick it up relatively quickly because last week I was asked to give more information on superheat subcooling and how that works. So I want to go into that, but I just wanted to mention, I mean, if you follow the stories on Instagram and you see the pictures that I posted in the community, you see that AHR Expo in Orlando, Florida is a blast. I literally met everyone that I wanted to meet. So there's so many great people here. There's so much product, so much seminars, so much podcasts going on, connecting with people, different parties on the side that you can join and connect. And it's an amazing opportunity. So if you get the chance to attend one of these, definitely take the chance. There is like it really like look at what you want to get from the expo, but there's a lot of new products being introduced. You can also check out old products, you can test products, you see anything from boilers, cooling towers, chillers, pumps to tools like you have Milwaukee, DeWalt, you have Navac, you have Testo, you have Fieldpiece. All the manufacturers are here. The hall is so big that it literally takes, I think, like 15 minutes to walk from one end to the other. So you have, I mean, I almost want to say thousands of booths because there's so many. I don't even know. Like the first day, I just walked around and I couldn't even see everything. But if you want to look at tools, it's a really good opportunity. And then in the end of the first day, I found out that they have three classes, and I looked over some of the schedules, and the classes are actually really amazing. So if you want to just get more knowledge, you can attend the classes. And then they also have live podcasts with like people that you know and trust, like AC Service Tech. So if you want to listen to those and you want to meet like those people, you can do that too. So it's just a great opportunity in general. So just want to throw it out there that next year it's gonna be in LA. So if you want to plan for that, you can get there and also, I met some people that follow me, so that was kind of cool. And I met some of the people that I follow, which was even also more, it's like amazing. So, anyways, just wanted to say that.
That's great. That's excellent. Sounds like
Yes.
a good trip.
Yeah, it was a lot of fun. I'll be posting more pictures in the community as well. And then lastly, so let's talk a little bit about subcooling and superheat, because that's what the question was that we got last week. To kind of get more of an understanding of subcooling and superheat, you have to understand refrigerant in its saturated state, which means that you have refrigerant as a liquid and a vapor existing at the same time. The way you remove heat from an area is through the phase change of the refrigerant. Like most of the heat gets absorbed by the refrigerant moving from liquid to vapor and then from vapor to liquid. So if so you have saturated refrigerant, which you have refrigerant existing as a vapor and the liquid at the same time. Now, if you want to understand superheat, think of the refrigerant, which exists as a vapor and a liquid. It is in the evaporator. Now it's moving through the evaporator. So you're picking up more and more heat. It's moving through, and now with a coil, blah, blah, blah. You're picking up more and more heat. So more and more of the liquid refrigerant evaporates and turns into a vapor. Now you get to the point where all of your liquid refrigerant has evaporated and turned into a vapor. So now you're at 100% vapor, but you're not past all of the evaporator coil yet. So you're still picking up heat. So what happens after that? That is what is superheat. And the best analogy that I can think of is when you're boiling water and you have a lid on top and you're collecting the steam up there. If you heat up the steam, or when you see the steam rising, when you heat it up past 212 degrees Fahrenheit, your steam gets hotter, but it's not gonna it's just gonna stay steam, you know? So the additional heat that you put in past the 212 degrees Fahrenheit, that is the superheat in the refrigerant. Obviously, refrigerants are designed to evaporate at a certain temperature, so you are allowing it to remove heat from the space and allow it to, reduce the heat load in the space based on the requirements of the customer, because refrigeration is all about comfort. So you're providing comfort to the customer. So superheat is the temperature the vapor refrigerant goes up to past, so you have the saturated refrigerant, you go 100% vapor, it has a certain temperature, and then whatever heat you pick up past that point, that is your superheat, and you get that on the evaporator. So you would be measuring superheat on the line leaving the evaporator, your suction side of the compressor. That's where you would be measuring the superheat. And then to go on to subcool, it's basically the opposite. So subcool is when you have your refrigerant as a saturated refrigerant, you have vapor and you have liquid. Now you're in the condenser, you're removing heat, now you have your condenser fan, so you're removing the heat from the vapor refrigerant. It gets into a liquid more and more, and at some point you have 100% liquid refrigerant, but you're not fully out of the condenser yet. So whatever amount of temperature you're cooling down the liquid past the point of where it's 100% liquid, that is your subcool. It's like you're cooling it past 100% liquid refrigerant, and that would be measured coming out of the condenser. So I should probably have visuals and draw it on the board and stuff, and put the condenser and the evaporator. That's probably easier, but here I don't have those tools available right now. So I hope my explanation makes sense. If there's a question you have right now, then just feel free to ask. But that is superheat and subcool explained. It's kind of like all words, and it's better to show. But let me know if you have a question on that.
I don't have a question. I don't know if somebody else has a question. Somebody join us, and I don't know if they have a question. I don't.
Okay. You can always put it in the chat. But yeah, so that's superheat and subcool explained. And that's also why when you're using the different methods to charge the system, you only would use that if you're low on charge, if you had a leak, for example, on the Schrader core or something, and you can fix it without removing the entire charge, then you would be using the subcool or superheat method to charge the system. Most technicians actually in the field that I know, they don't even like check superheat and subcool if their temperature split is good. Like let's say you have like 18 to 22 degrees temperature split across the evaporator coil, then you're like, okay, the system is cooling efficiently. You know that you're removing heat. Then you're like, okay, why do I need to charge it? But let's say there is a known leak. You have a Schrader core that's leaking. You replace the Schrader core. You know it's low on charge, and you want to just top it off. Then if you have a TXV, you use the subcool method to charge it because the TXV already regulates the amount of superheat coming out of the evaporator. So you don't, like, you cannot really measure that because if you add refrigerant, the TXV will just regulate and give you a constant superheat. So you want to use the subcool method to charge systems with a TXV, and you want to use the subcool method to, sorry, you want to use the superheat method to charge systems with a fixed orifice device. So that's what I wanted to cover for today. I hope that makes sense. I don't know if we want to take up anything else for right now.
Well, I don't have any other questions. I think that was the main thing that was covered last week, so I think it's pretty okay. I don't know if somebody else wants to get the
Yeah. Also, we have. I mean, that's different. So let's just wait a second and see if somebody has a question. But then I wanted to take up the.
You got mute. Hey, you got mute, and I don't
Let's see.
understand.
Let's see in the chat. 1 second. Okay. Well, there we go. I just wanted to do a quick announcement on the live troubleshooting, electrical troubleshooting webinar, which is going to happen on the 22nd of February. That's a Saturday. It's happening at 11 a.m. Central Standard Time. I will be posting in the community and will pin a post in the community so you can just sign up for that so I can send you the link to join on the day off. Also in March 8th, we are going to have an in-person meetup in Schertz, Texas, which is just north of San Antonio. Right now we have about 8 to 10 people confirmed. It will be in the afternoon, probably from like 2 to 5 p.m. If you guys want to hang out longer, we can probably do that too. You know, if you connect up with somebody and you just want to keep talking, you know, just feel free to hang out there. But it's at Willie's, which is the bar. They have a bar, they have burgers, they have seafood. Across the parking lot, there's also a pizza place, and then you have like somebody who wants to like play laser tag. There's an arcade, which I love laser tag, so I might be going there afterwards. But I just wanted to remind you, and I'll be pinning those events in the community anyways. But I just wanted to remind you that this is happening. Damn, this Florida sun is crazy.
All righty then. That sounds good.
Okay, that's all I have for today. Then thank you for joining. Oh, now you have a question. Really? Well, you check the data tag. You check the data tag for how much it's supposed to be, or you check the manual on your subcool. It's usually stated. I mean, if you're working on rooftops units, it's usually on your data tag. If you're working on split systems, it's usually on your condenser data tag. Otherwise, you can always Google it, or you can call the manufacturer. And no, I don't like the wall tools. Thanks for pointing that out. Just because I won one of them doesn't mean that I have to use it. All right. Well, I'm gonna say bye and then have a good day. Thank you for joining and enjoy your Wednesday. Have a good day, and I'll see you next time.
Okay, bye.
Okay, bye.